All right, some properties of limits that we need to know. The first one is the sum and difference rule. The sum and difference rule just says if I have some limits here, and it says limit of f of x as x approaches c is L, and the limit of g of x as x approaches c is m. If I decided I wanted to do the limit of f of x plus or minus g of x. So for example, if I wanted to find the limit of x squared plus x, then all I have to do is take the limits of those two functions individually and either add or subtract them depending on what I was doing there. The product rule is very similar, and it says if I wanted to do the limit as x approaches c of two functions being multiplied, so f of x times g of x, I can just find their limits individually and multiply those. The constant multiple rule says if I have a constant out front, so we'll call it k for constant, times f of x, then again I can just find the limit of f of x and multiply it by k, so k times L. The quotient rule, it's exactly what you would think. If I have two functions being divided, then I can just divide their two limits. The only thing I have to take into consideration here is that m is not allowed to be 0. It wouldn't work then. The last one is the power rule, and that one says limit as x goes to c of some function being raised to some power, and I'm going to put it as a fractional power just in case. I can still just find the limit of that function and then raise that answer to the power. So those will come in quite handy. So example 4 says find the limit of this function as x approaches c. The first thing we always try to do when we do these limits is to just plug the value in. Well, since I'm plugging in another value, or variable, this is really not going to be that tricky. So I just have to plug in c for all of the x's. So we get c cubed plus 4c squared minus 3. Those are our favorite problems. We're done. Same thing in letter B, the limit as x approaches c. We're going to get 4c to the 4th plus c squared minus 1 over c squared plus 5. Now I'd like you to try the next two and see what you get. For the first one, you should have ended up with -9, and for the second one, you should have ended up with 3. All right, and then on example 6, it says use a graph to show that the limit does not exist for this function, x cubed minus 1 over x minus 2, as x approaches 2. And you should recognize right away that there's something weird going on at x equals 2. We can't use x equals 2. It's not a part of the domain. And if you remember from last year when you did these types of problems, we call that an asymptote down on the bottom. So we're going to end up with a vertical asymptote. So what I would like you to do is take a moment to graph this problem, and I'm going to tell you you're going to have to change your scale on your axes here. So the top value is going to be 100, the bottom is -100, and then the scale here on the x's, you're going to go up by half for each one, so -5 to 5. So take a couple minutes, you can graph it on your calculator and help you plot some points and try to see what this looks like. All right, so here is a picture of what that graph should look like. And so we're trying to show that the limit does not exist as x approaches 2. Now I want you to just pretend that you're a little particle on this graph and you're marching along, coming over here on the right-hand side, marching along, and you're trying to get closer and closer to x equals 2. And as I try to get closer, look where this particle goes. It has to go all the way up to infinity. But that's what happens on this branch. But let's say our best friend, particle, is over here on the left branch, and it's marching and trying to meet at x equals 2. We had an important lunch date. And as it's traveling, it goes to negative infinity. So if I was on the right-hand side of x equals 2 and I had a lunch date with someone on the left-hand side, would we ever be able to meet for our lunch date? And no, so this one's always going to go up, this one is always going to go down, so therefore our lunch date would never happen. So here's what it looks like in limit notation. I'm going to kind of cover these up a little bit and we'll do a slow reveal. So a couple of notation things. The limit of our function as we approach 2 from the right-hand side, that was this guy over here, that one went up to positive infinity. And so notice that little plus there, that just means from the right. Now, the person on the left has a different notation. And so that one is, sorry for my ineffective work there, so limit of this function as x approaches 2 from the left was negative infinity. So that was this branch here that went down to the left. So what our conclusion statement would be, and this 3 dots here means therefore, the limit of f of x as x approaches 2 does not exist. If these two don't match, then this one cannot exist. So that happens to be the next definition on the top of the next page. The definition of one- and two-sided limits. And so this particular definition, and I apologize, the word if disappeared, but if the limit as we approach c from the right equals L, and the limit as we approach c from the left is also L, then we can write the limit of f of x as x approaches c with no specifications here is also L. But I want you to put a note here. Both sides must match. So we're going to write a second statement over here, and it says if the limit of f of x as x approaches c from the right is L, and the limit of f of x as x approaches c from the left is M, then the limit of f of x as x approaches c does not exist. Okay, those two don't match, then the limit does not exist. Does it feel like a Mean Girls montage here? So the limit does not exist. Some of you, if you've ever seen Mean Girls, you'll understand. If you haven't, you got to check it out. All right, last but not least, to end, we're going to kind of do some fun stuff with this particular problem in class on Tuesday. So what I would like you to do is work through this problem and at least try to get your best guesses at A through H using this picture here. Try to find all of those limits. Have that finished before you come to class. I look forward to seeing you soon.